Large language models as models of what the brain actually does in acquiring language, a view expressed recently by Professor Barenholtz. In my opinion, total unreality. Let's see why. To quote from Elan, associate professor, Florida Atlantic University, from a recent interview, Theories of Everything, Curt, we're forced to conclude that the mechanism the brain is using is the same as going on in these large language models. If we are using different mechanisms, it's extremely unlikely that the LLMs would work as well as they do. It forces the conclusion that there's only one way to do language, and that one way is the same in humans as in machines. Such a view can only rest on ignorance, some form of ignorance, or heavy misevaluation, in my opinion, of ecological psychology, Gibson, perception, memory research, cognitive psych, especially before the advent of AI, circa 1972. Let's look at just a few statements. The two embeddings. Elan argues that the brain learns a language per se in exactly the same way as LLMs, that is via next token processing. In our little schema to the right there, predict the next token. The man stirred the coffee with a blank. Spoon would be the logical fill-in, the most probable fill-in. So this implies a massive vector of co-occurrence, probabilities, stored in the brain, self-contained, just a pile of words. But he notes, it's in truth a pile of meaningless symbols. For meaning, there has to be a handoff from perception. To quote, the perceptual processes take place long before the handoff. A lot of stuff happens before it's tuned or turned into a linguistic friendly embedding, something an LLM could handle. At the end of that process, there is a conversion. Embedding, in his terms, a high-dimensional numerical representation of your token. For example, for English and Spanish, there's an underlying latent structure that is true of both. He goes on, when I see a microphone, there's a vector representation. And I don't mean the qualitative experience, don't want to get into the phenomenology. But there's something happening in my brain that is the representation of what it means to see that object from a visual standpoint. Well, let's make the microphone a dynamic event, coffee stirring. The representation is going to be a series of states. By definition, the computer can only take snapshots. It can only handle a series of states. So there'll be vector set after vector set. 10 seconds of coffee stirring would be quite a pile of vector sets. This would be the visual auditory embedding. He goes on, the word microphone is a point in a high-dimensional space. The experience of seeing the microphone is a point in an entirely different high-dimensional space. So the words coffee and stir, as part of the coffee stirring, are points in the vector space, a high-dimensional vector space. The linguistic embedding. The point is, this knowledge lives inside this linguistic embedding, he says. And then there is this other embedding, visual, auditory. And then the idea I'm inspired by, there's this latent space that captures certain universals that are common across these embeddings and make the translation possible. So a commonality, a common thing across the two different embedding spaces, but it's just going to be another vector representation in all likelihood, because that's basically all there is to work with in the computer model. But this is the structure of coffee stirring. I've noted it many times. It's a 4D multimodal event. It's a structure of invariance laws. Velocity flow fields, in this case a radial flow field, adiabatic energy or ratios, and inertial tensors carried over the haptic flow field, acoustical invariance, texture gradients, ratios, flows, all to be found in J.J. Gibson and ecological psychology. The invariants do not exist in a single static state, or for that matter, in a series of static states. Inertial tensors, adiabatic ratios cannot truly exist as a series of static matrices. This is a dynamic 4D structure existing over an extended, truly continuous not a series of static states time. It's an indivisible flow where each state, quote unquote, permeates the next, as though each state is a note, where the note is actually an artificial demarcation in a flow of sound. So each note permeates the next. It's reflective of previous history, the previous notes, where the dynamics grows, builds, the hand-arm fatigues, the coffee smell waxes increasingly strong, perhaps gets overwhelming, the clinking builds a certain quality, perhaps gets irritating. So we have the vector space, but this vector space cannot map to this, the concrete, dynamical, continuous, indivisibly flowing event. This event is not the abstract space that this is. This is why you cannot get away with this. Elan's statement, when I see a microphone, there's a vector representation. And I don't mean the qualitative experience, that is, that image of the external world, our sentience. Don't want to get into the phenomenology. But the phenomenology, qualia, in the 4D event structure, dynamically evolving, building over time, these are inseparable. You cannot parse them out. Let's go to learning language. Language is self-contained. It is simply a map of meaningless symbols, says Elan, simply a topology among symbols. In language, all you have is the next token generation. The bottom line of what language is unchanged in this account. Curt says, how do meaningless squiggles cause action? Elan, yes, that's the question. What we know from LLMs is that we don't need that to be proficient in language. That is, we don't need perception, action, motor action. That's the starting point. You can learn language independently of that stuff. The ability for me to make someone get up and move, then he goes on, taking up again. Language can be learned completely on its own. The relations of these meaningless squiggles, two independent processes. Firstly, learn how words play with one another. In other words, the LLM model. Curt, okay, that one is solved. That one is solved. Amazing what Curt is buying into. Turtle speed brain does massive matrix operations on a vector space of, say, 50,000 words, computing co-occurrence probabilities. This is requiring petaflop S-days of processing power, where one petaflop is 1 quadrillion floating point operations per second. S-days, so 60 seconds per minute, 60 quadrillion floating points per second per minute, 60 minutes per hour, 24 hours per day, processing away. And this is a delicate set of weights. Destroying even some of these wrecks the computations. And these weights are stored in the brain, implying a fixed network architecture required to maintain the weights. But it's installed in the fluid, constantly changing, birthing and dying massive cells that is the brain. Quite miraculous. All when we have no idea where or how words are stored in the first place. Remember this article, Pepple and Asardi. We don't know how the brain stores anything, let alone words. I discussed this in my 4th installment on is experience stored in the brain in the first place, on the problem of words. Curt says, or Elan says, yes. Then, secondly, we learn that there's perceptual phenomena. We learn that there's things on top of other things, actions we want to take, like coffee stirring, things my dog understands. Well, let's consider the integrated approach, not two independent processes. There's J.J. Asher's model and experiments. Note the first one, the strategy of total physical response, an application to learning Russian. Lots of these were done. I'm not listing them all, like on Japanese, like Spanish. Note the title here, the child's first language as model for second language learning. The idea that child dwells in an environment of commands. Johnny, pick up the spoon. Susie, eat the cereal. Mary, wash your hands. Asher's idea, model second language learning on first language learning. This was very successful. You learn by learning by responding to a series of linguistic commands. Tie your shoes, break the pencil, grab the spoon. perhaps spoken in Russian. But you actually tie your shoes. You actually break the pencil. So perception, action. That is, language learning is tied to motor action, totally integrated. Why is this the natural case? Joe, stir the coffee. The verbal phrase, Joe, stir the coffee, is part of the acoustic structure of the multimodal event. We can redintegrate the event. We bring the event back by moving the body into the same motor attitude, as Bergson called it. That is, act out the stirring. The phrase comes back with the remembered event. Redintegration from Wolff, Christian Wolff, 1732, disciple of Leibniz, describing the phenomena, quote, part of a present event, that is the pattern, brings back a past event with a similar pattern. For example, a rustle in the grass brings back an experience of encountering a snake. This is ubiquitous in our experience. We experience this all the time, bring these recall of events via current events. Who is the great descriptor of the patterns? Gibson. It's the structure of invariance laws. This is ignored in cognitive science. All this is part of memory, storage of events, retrieval, redintegration of events. Look at the inverse case, a loss of memory. Bergson noted this. Ribot's law for aphasia. Word classes are lost in this order. Proper nouns, like Sam and Joe, then nouns, spoon, coffee. Verbs, stirring, mixing. Miraculous, because if words are stored in the brain, then apparently the memory loss goes from the place that proper nouns are stored, and then it hits the place where nouns are stored, and then the place where verbs are stored. Do we really think there's any such places and that a destruction into cells goes in that order? The body's ability to easily assume a motor attitude with respect to action, for example, stirring, we could argue makes it easier to redintegrate the word. Verbs are easiest. Nouns increasingly harder than pronouns. There's a relation to bodily action here. Verbs are simple, easy actions, easy to recreate. The object, a nexus of actions. A spoon can stir, it can be lifted, it can be thrown, it can be used as a catapult, etc. More complex. Person, way more complex. Curiously, these so-called words that are lost, destroyed by a knock on the brain, can be restored. But they come back in the inverse direction. Verbs first, then nouns, then proper nouns. Quoting Bergson, verbs in general, which essentially express imitable actions, are precisely the words that a bodily effort might enable us to recapture. Proper nouns, on the other hand, being of all words the most remote from those impersonal actions which the body can sketch out, are those which the weakening of the function will earlier affect. So this is another of Elan's weak points, since for AI, the body has zero integral, decisive, necessary role. Again, as he naturally reverts, we just need the pile of words, and that's it. Elan says, there is no static definition of what a microphone is. There is not a set of facts statically. What the microphone is depends on what question I'm asking. There is not a set of facts perceptually. There's an infinite number of facts about the microphone. Very true. Equally true of coffee cups and coffee stirring. All these words, swirl, mix, brown, cup, these are just some aspects we have dissociated from the event. The concrete event infinitely overflows the set. They are integral parts of the event. They do not have to be associated. For example, to move the coffee, the very physics of the event intrinsically entails an instrument to move the coffee like a spoon. The instrument requires a force, like a hand, an arm moving the hand. The liquid must be constrained. You need a cup. Otherwise, the liquid's all over the tabletop. The coffee cup needs to be supported. You need like a table to support it, and on. So they do not have to be associated. This is the absurdity of associationism, which is AI on steroids. The multimodal event can never be reconstructed from this set of vectors, these aspects we've just simply dissociated from out of the whole concrete, dynamically transforming event. So this infinite number of facts, this infinity of possible facts about an event is driving AI, cognitive science, in my opinion, to this. The entire multimodal 4D event in full detail must be stored. This is required for analogies. I've noted this many times. For analogies are equally exhaustible. And analogies can emerge from comparing these events in their wholeness, in their concreteness, without necessarily these words having been identified. This in turn requires a four-dimensional memory. The event, the squishing baseball, or basketball, the swirling coffee, stirring coffee, this is a dynamically transforming event over an indivisible flow. The being there, our guy, is an indivisible flow. Inherently, the events, the being itself, our events, is an event. It's four-dimensional, 4D being. And the experience is concrete, multimodal, optical, sonic, kinesthetic, etc. All there, shall we say, four-dimensionally. This set of vectors is a unimodal, homogeneous representation. No computer memory escapes this problem. You can say, yes, I've got auditory aspects stored, I have olfactory aspects stored, acoustic aspects stored, optical, but you're fooling yourself. It's still simply a homogeneous memory, say magnetic cores. So the invariant structure of the event modulates the brain conceived as a dynamic oscillating mass, driving a structured wave through 4D experience. The redintegrative wave, let's say. This structure, this invariant structure, redintegrates an event or set of events with similar structure. Now, Elan will say, what we call long-term memory, LTM, is just fine-tuning of the weight. So we're back to the homogeneous memory. It's information that gets embedded in the weights of the model. Our brain does not do retrieval at all. All we do is fine-tuning, then next token generation, autoregressively. And we don't actually ever retrieve per se. Well, beside the fact that this is flying in the face of our experience in all of memory research, I'll simply note this. Redintegration is affected by parametric changes in the Q event's invariant structure. The Q event in our snake model would have been the rustling grass, bringing back the experience of the snake slithering by. The invariant structure can be manipulated. The parameters involving this are involved in the structure. The amplitude of the coffee stirring, for example, can be changed. The resistance of the liquid can be changed more toward mixing cement. The velocity flow field can be changed much, much slower or much, much faster, etc. As you change these parameters in this invariant structure, you're changing what events will be retrieved. Could be an entirely different set of events. Memory research literature is filled with this implication. It's simply not noted, other than in some papers that I've read. What is syntax learning? Something in which larger language models excel, in which Elan is basing some of his thought on, I think, bouncing off of this. Well, the subject-verb-object structure obviously is reflective of actual events in the concrete world. What we perceive, the piston crushed the ball, the hammer smashed a chunk, the foot crushed a tomato. This is just something obvious, but take something a little more abstract. Take the syntactic structure. What coffee did they stir more of? Doesn't quite strike right. Linguists have talked about a gradient of syntactic acceptability. In other words, there's more going on than just the pure syntax. There's something behind it, our perception, our understanding of the world, our concrete experience. Think of a fair, a concession stand selling all kinds of different coffee. Now that you ask, which coffee did they stir more of? Well, it's not even registered that as a problem. How about this one? Which blackboard did they stir more of? Well, this is hard to grok because blackboards do not fit in the invariance structure of stirring. It's very hard to stir blackboards unless you're thinking of some strange event, like they're crushing blackboards, pulverizing it, putting the particles into a coffee cup and stirring. Then you might ask, what blackboard did they stir more of? So, in my opinion, we'll have to return to the theory of cognitive grammar, which is just in its infancy, barely begun and abandoned as the focus on the computer model grew. People like Paul Dean, Grammar in Mind and Brain, or George Lakoff. These folks tended to talk about image schemas. For example, the piston crushing something there would have been an image schema. Coffee stirring would have been an image schema. These image schemas help drive the syntax, it's the grammatical construction. They're obviously invariant structures, the coffee stirring, but because the linguists weren't familiar with Gibson and ecological psychology, and conversely, the ecological psychologists weren't real and haven't been real astute in relating their psychology, their findings to linguistics questions. It just hasn't been noticed. But in my opinion, this is where you're going to have to go, to this kind of deeper structures actually driving the learning of the syntax of the language. So a last note. Elan is not alone in this view, namely that LLMs are capturing what the brain is doing with respect to language. Take this paper, Dissociating Language and Thought. Look at the sentence in red there. Based on this evidence, we argue that contemporary LLMs should be taken seriously as models of formal linguistic skills. Again, just reflecting Elan's position. You can see the other part reflected, number 2 there, in the bottom sentence. In the purple, non-language specific cognitive capacities are needed too. In other words, perception, action, cognition. Another paper by Piantedosi. Modern language models refute Chomsky's approach. In other words, these models have replaced Chomsky, he's arguing, and are now by default the new basis of a theory of human language understanding. Well, given this assumption, Elan's attempt to link these two worlds, the self-contained linguistic one of LLMs, just a pile of words, nothing more, to the one of perception, this is an inescapable effort, and, in my opinion, a lost cause. For me, all based on an astounding neglect of Gibson's ecological psych, the oral literature of cognition, misevaluation of Piaget and his implications for cognitive development, memory research, and much, much more. And AI folk, even the AI critics, like premier critic like Gary Marcus or Eric Larson, even these are not close at this point to considering any of this. So next we'll see, again, I point your attention to this book. A lot of this is discussed and much more on time, consciousness, and those kind of background problems that are very much involved. So till then, next time, signing off.